Yeah, hi everyone. Welcome back to my class. This is going to be the last session on linear algebra, and as I promised, I have covered various concepts on linear algebra. And as far as today's demand is concerned, linear algebra is one of the very important topic. Uh, okay, that you have to understand, right? Yes. So let me check whether my voice and everything is fine or not. Okay, so it looks everything goes well. Yeah, perfect. Okay, so what I'm supposed to do here is I will be discussing here the basis and the dimension, the concept of basis and dimension. Already I have discussed about what is linear independence, okay, when we can say the vectors, given vectors are linearly independent, okay, and so on and so forth, right? So those things I have discussed already. And in this session, what I'm supposed to do here is I will be discussing about the basis and the dimension, right? So I'm just keeping here myself okay, little small one so that you guys can take a look on the whiteboard or favorite board, right? So if somebody is live there, they can confirm me whether my voice and everything is fine, then we can proceed ahead, right? So in this session, I'm going to talk about the basis and the dimension, right? Okay, so these are the topic which nobody teaches in linear algebra courses when they teach about gate exam, okay? And yes, so let me check whether my voice is fine or not, because you guys are, I think, yeah. Going to talk about perfect. Yeah, it looks good. And the dimension. Perfect. So what I'm supposed to do here is I will be discussing about basis, but before talking about basis, as I told that you can only discuss about basis when you have the concept about linear independence, Li, as well as you should know the spanning sets, right? The concept of spanning set you should know, right? Spanning set. Okay, the intersection of these two concepts will give you the basis, sorry. Okay, like Li as well as spanning sets. Okay, the intersection of Li as well as spanning set is going to give you the concept of basis that you have to understand. Basis is nothing but the set of vectors. Okay, the set of vectors that you have to understand. Understood? Basis is going to be what? The set of vectors, right? So okay, so remember, set of vectors are those vectors which are linearly independent, and you have to understand this also. What is the meaning of spanning sets? In other words, we call it generating set. Generating set. Okay, generating set. So basis will be basically, suppose this is a linearly independent set of vectors, and this is having the spanning sets. Okay, spanning set. Okay, and you can say here this is going to be the Li vectors. So this intersection point is going to be called as a basis, right? So basis is going to be the set of vectors which are linearly independent, and also they span the space. You can say they span the space, right? So what kind of space what we want to talk about here? What is spanning sets? What is generating sets? These things we are going to discuss. Okay, perfect. So please confirm if my voice and everything is fine, because I think if voice is fine, then only we can proceed ahead, right? Let me check here. So what kind of space? Yeah, it is fine. It looks good. So what we can do here is, yeah, we will discuss first what is the meaning of linear span, right? Linear span. Linear span. What is the meaning of linear span? So what we will say here is that we will understand first what is linear span, then we will understand what is spanning set, or you can say what is you can say what is generating set. Then we will discuss about the basis as well as the dimension, right? So linear span of vectors. Okay, so let me consider some of the vectors here. Linear span of a vector. Okay, linear span of vectors, you can say v1, v2 and v3 and so on, vn. Okay, so there are some vectors given v1, v2, v3, okay, and so on and so forth. So we will say that span of these vectors, okay, span of these vectors, okay, span of these vectors will be what? v1, v2, v3 and so on, vn is going to be, okay, is going to be what? The linear combination of all these vectors. Okay, what will be span here? v1, v2, v3 dot dot vn will be the linear combination of vectors. What? Linear combination of vectors. So we can write this as linear combination of vector. What is linear combination of vector? We are going to multiply some constant, okay, scalar constant with the vector, okay, plus scalar constant with the vector. Okay, so that is known as linear combination of vector, right? So we are going to write here, suppose we will say here lambda I is a scalar constant times vi. Okay, okay, that you have to write. Okay, so I hope this makes sense to everyone, right? This is very important to understand. Okay, so what is span of these vectors? Span of these vectors is nothing but what? The linear combination of given vectors. Okay, this is going to be the linear combination of the vectors. Okay, that you have to understand always, right? The collection of all linear combination of v1, v2 that's vn is called the linear span of vectors. Okay, that you have to understand. So linear span is nothing but what? Linear span is nothing but the linear combination of vectors, given vectors, whatever vectors you have, v1, v2, v3 dot 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 vn. So I hope everybody knows what is the meaning of linear combination of vector and how to write linear combination of vectors, right? In fact, whenever system of linear equations are given, so we take some, we form a coefficient matrix. So those column vectors can be written as linear combination of column vectors, right? And which gives you the right hand side. You can say b if b is given. Okay, and if b is not given, suppose we have got two kind of equation. One is a and one is ax equal to 0. Okay, so this is basically known as null space. Okay, null space. Okay, so all these x will create a null space here. In this case, all these, yes. So I believe this is fine for all. Okay, so you have to understand these concepts. These concepts are very, very important to understand. So linear span, I hope everybody understood what is the meaning of linear span, right? I want to talk about here. What is spanning? Yes. Perfect. So let me move ahead and talk about spanning set. What is the meaning of spanning set? Spanning set. Okay, don't take these terminology as tough as they look, right? Spanning is nothing but generating. Okay, spanning sets. Spanning sets means generating. Okay, generating set. So what we are going to consider, again we will consider some set of vectors. Okay, you can consider some set of vector like v1, v2 and so on, vn, right? Okay, so this vector set is said to be the generating set, or you can say the vector set of this is said to be, okay, is said to be a spanning set, right? Spanning set, or you can say generating set. Okay, of vector space v, right? Vector space v if, okay, if, okay, for any vector, okay, for any vector v, okay, there exists a scalar, there exist scalars, right? alpha 1, alpha 2, and so on, alpha n, right? In, you can say, in real space R, right? So this statement you have to remember. This statement is very important. Whatever statement we have talked till now regarding linear combination, linear independence concept, right? Everything looks similar only. You see here again we are considering some bunch of vectors. They satisfies all those properties, okay, like closure property, right? If you add two vectors, right, so you should be in the same space. That is the meaning of closure property, right? Means these vectors are closed under addition. These vectors are closed, you can say, they should be having the linear combination of them, right? These concepts you have to keep in mind, okay? So yes, so any vector can be generated, okay? Any vector can be spanned with the help of linear combination of these given vectors. That is the meaning here. Spanning set means what? Any vector can be generated with the help of given set of vectors, okay? Whatever vectors are there, v1, v2, v3, and so on, and vn, okay, they should be able to generate a new vector, you can say, or some vector, and that vector should belongs to the same vector space, okay? That you have to make sure. This is very important concept, right? I hope this makes sense to all. Yes. Okay, so this is very important. So v1, v2, v3, vn is said to be spanning set, or you can say generating set of vector v if for any vector v there exist these scalars like alpha 1, alpha 2, dot dot alpha, and you can also say lambda 1, lambda 2, lambda n in R, okay, in R. So you can write that new vector or the vector which you want to generate with the help of these linear combination. You can say sum alpha I vi going from 1 to n. And what is this? This is basically the linear combination of v1, v2, and so on, vn, right? Like alpha 1 v1 plus alpha 2 v2, okay? So any vector can be generated or spanned by the given set of vectors, okay? That is just a concept, right? So already I have explained what is the meaning of linear combination, so I think everybody should be familiar with that, okay? I hope this makes sense to all, right? Okay, so okay, this you have to make sure. If you're writing linear combination of given vectors, so the new vector which is being spanned or generated by given set of vectors, okay, like when we solve system of linear equation, right? When we solve system of linear equation, so whatever vectors are there here, right? Whatever vector we consider, and whatever vectors are present in a matrix, right? Like column vectors, right? So they are what we are writing them as a linear combination of column vectors, a linear combination of column vectors, okay? So what they are doing, they are generating this vector b. If they are not able to generate vector b, okay, if it is a non-homogeneous system of linear equation, so we'll not say that they span the set, right? They span the set. That you have to understand. This is very important. So in most of the sessions you will find that they just talk about this, right? Ax equal to b or ax equal to 0, that's it. These are the new terms, okay? These are the new terminology which you have to understand. So linear combination of column vectors, right? Okay, so I hope this makes sense. So already I have told you how to investigate, how to systematically find the linear combination of vectors, right? So suppose we have got any vector x, y, g, right? So they can be spanned, okay, with the given vectors. You can say v1 times some vector. You can take any vector, right? So right, we can say that this is lambda 1 v1 plus lambda 2 v2 lambda 3 v3, okay? So this is just a linear combination of given vectors, right? So I hope this makes sense. I hope everybody understood what is the meaning of linear span, what is the meaning of linear spanning sets, right? Okay, and already everybody is familiar with linear independence of vectors. सबको linear independence of vector पता होना चाहिए, ठीक है? सबको लीनियर कॉम्बिनेशन ऑफ वेक्टर्स पता होना चाहिए, और जो भी लेक्चर मेरे लाइक पीपल हु हैव वॉच्ड माय सेशंस राइट अराउंड 10 to 12 सेशंस, तो उनके तो रग रग में हो जाना चाहिए अब कि व्हाट इज द मीनिंग ऑफ वेक्टर्स। तो हम लीनियर अलजेब्रा पढ़ रहे हैं लेकिन वेक्टर्स का यूज बहुत ज्यादा है, ठीक है। Okay, that you have to understand because today's demand is linear algebra only. Okay, because in machine learning, to go for data analysis or any kind of job, right, data scientist in future, so machine learning like linear algebra plays an important role to handle data, right? So we'll take some example here, right? So suppose we have been given a vector. Okay, so example number 1. So the vectors are given, right? The vectors, you can say 1 0 0. Okay, these are the some standard vectors. Okay, in future we will call it basis vectors also. So 1 0 0 0 1 0, sorry, this should be 0 here, and next vector is 0 0 1. These are the some important and standard basis vectors. Sometimes they form okay, the vectors form a spanning set, of R3. What is the meaning of R3? I think everybody understood. There are three components. They are real components in the vector space. Okay. So for any vector, you can say, you can write here v1, v2, v3, right? That vector belongs to R3, right? Okay. So you can always write these v1, v2, v3 as a linear combination of these vectors. Okay. You should be able to write that. Okay, so I'm just going to write here. You see, v1 v2 v3, I'm going to write like v1 times 1 0 0, v2 times 0 1 0, and v3 times, okay, v3 times what, okay, so these are the components, lambda v1, lambda 1, you can say lambda 2, lambda 3, and these are the vectors. Okay, so don't get confused. You can also write lambda 1, lambda 2, lambda 3. Okay, so this is basically 0 0 1. Okay, so you see here, this vector is being spanned by the given vectors. Okay, we are able to generate a vector v1 v2 v3 which belongs to the same vector space, okay, with the help of linear combination of given vectors. Okay, so I hope this makes sense to all. ठीक है, तो आप लोगों को कंफ्यूजन में नहीं होना चाहिए, क्योंकि आपको, अगर आप प्रीवियस लेक्चर्स देख चुके हो, लाइक लीनियर कॉम्बिनेशन क्या होता है, लीनियरली इंडिपेंडेंट क्या होता है, ठीक है, तो आपको यू शुड बी वेरी गुड एट ऑल दिस कॉन्सेप्ट, ठीक है। कुछ लोगों को डाउट होता है कि सर ये स्पैनिंग सेट क्या है, हम तो अभी तक सिंपल दो मैट्रिक्स लेते थे, मल्टीप्लाई करते थे, सर ने मुझे रैंक बताया था, सर ने मुझे ये बताया था, मैं तो ऐसे करता था। लेकिन अब अगर इस तरीके से आप पढ़ते हो तो दिस इज द रियल वे ऑफ स्टडिंग लीनियर अलजेब्रा, ठीक है, यही लीनियर अलजेब्रा का रियल वे है। ये मुझे भी आइडिया नहीं था व्हेन आई वाज प्रिपेयरिंग फॉर गेट इन 2013 14 15 16, राइट, दोज इयर्स, ठीक है, उस टाइम मुझे भी आइडिया नहीं था कि दिस इज लीनियर अलजेब्रा विल बी वन ऑफ द पावरफुल टूल in machine learning and artificial intelligence. So after pandemic, everything started coming into picture, right? So ये आपको याद रखना है, ठीक है। So ये वेक्टर क्या है, लीनियरली स्पैन्ड है, ओके, ठीक है। ओके, so the question is when the vector will not span the space. I mean, when what is that situation when you can have like, as I said that here, what I have written here, these vectors are spanning, okay, the vectors form a spanning set. Okay, when vectors will not span the set, okay, that you have to understand. Okay, so I think you have understood, you have seen that the systematic way of investigating linear combination as well as linear independence, right? So whenever the solution is not there, okay, whenever the kind of inconsistency occurs, okay, while solving the system of linear equation, right, so if solution does not exist, it means that these set of vectors will not span the space, right? That you have to keep in mind. Okay, so there are some examples which you will find. Okay, so suppose I take one example here. Just I'm not going to solve everything. Okay, I will just give you the concept here. So suppose we have got one example, right? Suppose these vectors are there, right? 1 2 3, right? And 1 3 5 1 5 9, three vectors are there. Okay, and I'm saying that they do not span the space, do not span R3, right? They do not span the vector space. Okay, for any vector, you can say v1 v2 v3. This is one vector, right? And these v1 v2 v3 are the component, right? So v1, we can write v1 v2 v3 as a linear combination of, you can say, lambda 1 times 1 2 3, okay, plus lambda 2 times 1 3 5 and lambda 3 times 1 5 9. Okay, now you try to solve this. Okay, so how you're going to solve these things? Okay, how are you going to solve these things? You can take, this is one column, this is second column, right? And this is third column, right? Okay, so you can form a augmented matrix. Okay, so you can form augmented matrix. Okay, A given B, you write here all these things like 1 2 3 and 1 3 5 and 1 5 9. Okay, and here you write right hand side, that is, here in this case it looks like a left hand side, right? Okay, v1 v2 v3, v1 v2 v3. Okay, and when you apply the row app operations, I mean, just try to reduce it. Okay, by applying some elimination process. Okay, so if you apply the elimination process, okay, so you might get like this: 1 1 1 0 1 3, and you get, suppose you got 0 0 here, right? And here also v1 v2 minus 2 v1, and this is v3 minus 2 v2 plus v1. You got this situation. Okay, after applying this matrix, you will obtain after elimination. Okay, after performing elimination, you can say. Okay, so in this case, what you can conclude here is that the given vectors do not span the vector space. Okay, for any vector v. Okay, okay, what is the meaning of that? That vector v cannot be generated from the given set of vectors, right? You take any set of vectors, right? Okay, you take any scalar constant and multiply and try to generate that vector. You will not be able to do. Why? Because in this case, you see, this is inconsistency. Okay. Inconsistency means no solution. Okay, if there is an inconsistency, no solution, right? So you can't generate the vector space. I believe this is fine for all. Yeah. Okay, so those vectors which spans the space as well as they are allied vectors, okay, are known as bases. Okay, those vectors, those vectors which are allied as well as spans the space. Okay, spans the vector space. Keep this in mind. Okay, whenever you solve this, it should give you the solution, right? So what is basis here? That you have to understand. Basis is nothing but the vectors which are allied vectors and vectors which spans the space. You can say spanning sets, right? Okay, so their intersection is going to be known as basis, and basis is nothing but the set of vectors. Okay, and what kind of set of vectors? They should be allied and they should span the space. I hope this makes sense, right? And the number of vectors which are present in the basis is going to be the dimension of that vector space. Okay, that you have to understand, right? So dimension is a number, dimension is going to be a number, and vector is what? Vector is going to be the what? Vector is going to be the sorry, basis is going to be the set of vectors which are li as well as they span the space, right? So please take this important concept, okay? And if you fail to understand it, reach to me, okay? I think everybody is familiar with the important tool, okay? The important tool is what, guys? Important tool is elimination, right? In entire algebra, right? If you know elimination, you should be able to decide whether solution will exist or not, okay? There can be unique solution, there can be infinitely many solutions, okay? And there can be no solution as well. If no solutions are there, means that given set of vector do not span the vector space for any vector, means you cannot generate right hand side of the ax equal to b format, okay? If there is a non-homogeneous system of linear equation, right, so you cannot generate that vector right hand side of vector with the help of linear combination of column vectors. If this condition happens, it means the given set of vector do not span the vector space. That you have to understand. तो मैं फिर से बता रहा हूँ, spanning is nothing but generating. Right hand side को आपको generate करना है with the help of linear combination of what? Linear combination of column vectors. ठीक है? तो आप अगर आपके पास सिस्टम ऑफ लीनियर इक्वेशन गिवन है तो आप कर सकते हो. अगर आपके पास वेक्टर गिवन है तो भी सिस्टम ऑफ लीनियर इक्वेशन ही है, क्योंकि vectors, after all, from where we are getting these vectors? We are getting these vectors from the system of linear equations. When we form a matrix, okay, we get column vector, okay, column vectors, right? I hope this makes sense. ठीक है, ये चीजें समझना थोड़ा सा लगता है कि अरे ये क्या है, बट एक बार समझ आ गया ना, लाइफ इज वेरी सिंपल. ठीक है, आप कहीं भी इंटरव्यू देने जाएंगे, IIT बैंगलोर, IIT बॉम्बे, राइट, इन फ्यूचर व्हेन यू क्रैक गेट एग्जाम, you will be going with the confidence, right? और थोड़ा सा जब वहाँ एग्जाम होगा आपका फर्स्ट सेमेस्टर में, तो आप थोड़ा लीड करेंगे क्योंकि आपको थोड़ा सा रियलिटी पता है. ठीक है, और अगर आप सिंपली आपको पता है कि मैट्रिक्स कैसे मल्टीप्लाई करते हैं, इनवर्स कैसे निकालते हैं, और ट्रिक के पीछे पड़ेंगे तो फिर कुछ नहीं होने वाला है. ठीक है, ओके, गेट में रैंक आ जाएगी, गेट में रैंक आ जाती है क्योंकि लीनियर अलजेब्रा बस इंपॉर्टेंट नहीं है, देयर आर मेनी टॉपिक्स. आजकल बच्चों का क्या होता है कि दे विल बी एबल टू गेट द रैंक, राइट, लेकिन जो रियलिटी है वो नहीं पता होती है. दिस इज माय एक्सपीरियंस फ्रॉम द पास्ट 7 to 8 years I have been into teaching area. So I have been coming across different sort of student, क्योंकि मैं भी एक स्टूडेंट था और अभी भी हूँ, राइट. ठीक है, तो आपको समझ में आना चाहिए कि ये चीज अगर मैं बात कर रहा हूँ तो दिस इज वेरी इंपॉर्टेंट फॉर यू. ठीक है, तो basis, I hope everybody understood. Basis is nothing but the set of vectors which are li. Li means linearly independent vectors as well as they span the space. Okay, so basis is linearly independent set. What is that? It is li set, you can say li set that span, or we say sometimes create or generate. So span meaning what? Span meaning create or generate, okay, a vector space V. Okay, generate a vector space V, right? I hope this makes sense. This is known as basis, and this diagram you have to remember. अगर आपको ये डायग्राम याद है, मतलब मैंने जो मेन डायग्राम दिखाया यहाँ पर, तो आई होप यू विल नेवर फॉरगेट दिस, राइट. नाउ व्हाट इज द डायमेंशन? डायमेंशन इज अ नंबर, रिमेंबर. Dimension is what? Dimension is just a number, okay, number of vectors which are in the basis. Okay, so number of element in a basis, the number of element in the basis, okay, is called dimension. Okay, dimension of the vector space V. Okay, I hope this makes sense to all, right? So this is very important concept. ठीक है, ये बहुत ही इंपॉर्टेंट कॉन्सेप्ट है, आपको याद रखना है कि बेसिस क्या होता है, डायमेंशन क्या होता है. अगर मान लो ऐसा वेक्टर सेट है, सेट ऑफ वेक्टर है, दे आर लीनियरली इंडिपेंडेंट बट they do not span the vector space. If they do not span the vector space, it means they are not considered to be as a basis. Okay, उसको हम लोग बेसिस नहीं बोलेंगे, ये आप याद रखना। बेसिस के लिए दो इंपॉर्टेंट कंडीशन है, one is li and second one is very important condition, that is spanning the set. Okay, that is spanning the set. Okay, the number of element in the basis is called dimension of the vector space V. I hope this makes sense to all. If you guys are having any kind of doubt, you guys can also ask me. ठीक है, क्योंकि इस तरह कॉन्सेप्ट सीखना इज you will never find on a YouTube like people who teaches for gate, right? So they never teach these concepts, right? So I hope this makes sense. So number of element in the basis, number of element means what? Number of vectors which are li that spans the vector space. Okay, is the basis called dimension of the vector space. चलो, so next definition of dimension you can write here. Definition of dimension. So remember, dimension is a number and basis is what? The set of vectors. So you can say that number of li vectors, yeah, number of li vector, okay, that which can span a vector space, which can span a vector space. Okay, so this number is basically called as dimension. Okay, these are the definitions that you have to understand. Okay, so every vector in vector space V, okay, you should be able to write as a linear combination of basis vector. That is what the meaning. Okay, that is what the meaning is. So मान लो तुम्हारे पास basis vector given है, कोई भी vector if I give you, any vector if I give you, you should be able to write them as a linear combination of given basis vector. That is what the meaning of the basis. Okay, that correspond to the spanning sets. Okay, you should be able to generate, you should be able to create any vector, right? For every vector I'm saying, right? So for every vector in V means in vector space can be written uniquely as a linear combination of basis vector. Okay, so if somebody will ask the vector space, okay, like you have got a null space, right? So what is the dimension of null space? Null space dimension is always 0. That you have to keep in mind. Okay, okay, suppose we have the vector space which is also known as null space, where 0 is one of the element, right? Is defined. It is very important concept to have dimension 0. Okay, dimension 0. So if somebody will ask what is the dimension of null space, so you can always tell dimension of null space is gonna be what? The 0. I hope this makes sense to all. Okay, yeah, so this is how we find the basis of basis and dimension. And one more concept is there is a definition of rank of a matrix. So you should know there are various definitions of a rank of a matrix. Just I'm going to give you some of the definition of rank of the matrix, right? So you have to remember that rank of the matrix. Okay, what are the definition we can give for the rank of the matrix? Rank of the matrix is very, very important, right? The very first if suppose I say that one matrix is given, that is A matrix, right? So rank of a matrix A, basically we denote like row of A is going to be the number of pivots. This is first definition I prefer to be adopted by each engineer, everybody, okay, so that you should never be confused, right? This definition is applicable in any kind of matrix, whether it is non-square matrix or a square matrix, okay? Because most of the students, what they do is, while finding the rank of the matrix, they go for, finding the determinant of the matrix, right? So they try to find the rank of the matrix in terms of determinant. What they do is they try to determine the singular matrix, okay, and depending upon that, they decide, okay, rank of the matrix is going to be this. So if the big matrix is given, then checking that might waste your time, right? So consuming those kind of a content is not going to help you in the gate exam, right? So what you have to do here is, yeah, you will get answered. Rank in terms of determinant is easy, okay? If your 3 by 3 matrix is given, you try to find the determinant of the matrix, right? So if you are going to get the determinant of the matrix is 0, so rank is going to be always less than the order of the matrix, right? But if you know the elimination process, because elimination process plays an important role while solving system of linear equations. So you can also find the number of pivots. Number of pivots is going to be the rank of the matrix. Also, rank of the matrix definition is number of linearly independent rows. Okay, number of linearly independent rows. Okay. Second definition, number of linearly independent columns. Right. So rank of the matrix is going to talk about number of pivots. First of all, it can also tell you how many number of linearly independent rows are there, number of linearly independent columns are there, okay, and what is the dimension of column space, dimension of column space, okay, column space of the matrix, what is the dimension of row space of the matrix, right? That also will be you can always find, okay? So these are the 5 definitions of rank, okay? Yes, hi Devans, it's okay, no problem, right? So I think you will be able to revert back my session and you can start watching, right? So I have been talking about basis as well as I discuss about dimension, right? So you have to watch previous sessions in order to understand the concept of linear span. You have to understand, in order to understand the concept of linearly spanning set, right? You should be having the idea about how to write linear combination of vectors, what is linearly independent. So rank of the matrix can be discussed in these manners, okay? There are 5 to 6 definitions, okay? I hope this makes sense, okay? Okay, okay, let's move ahead. So you can see this, I think it was not visible, right? So number of linearly independent column, dimension of column space, and so on and so forth, right? So fine. So rank of the matrix can also be determined with the help of rank in terms of determinant, okay? So what is the meaning of rank in terms of determinant? You can always find the rank in terms of determinant. A rank in terms of determinant can be found out. First of all, if it is a square matrix, so this concept is only valid in case of a square matrix. So if square matrix is given, okay, because you cannot find the determinant of the matrix if it is not a square matrix, right? So first of all, if a square matrix is given, then only you try to find the rank in terms of determinant, right? What you can do here is if the square matrix is given, okay, find the det of that, find the det of matrix A, okay? If that is equal to 0, it means it is a singular matrix. Okay, it is a singular matrix. Then what you can say, the rank of A will be always less than, okay, always it will be less than, it will be less than, you can say, the order of the matrix, order of matrix, or you can say number of unknown. Okay, though rank of the matrix is always less than or equal to the order of the matrix, right? But I mean number of column and whatever, right? Suppose m by n matrix is given, right? Suppose the matrix A is given and it is m by n matrix, right? It is not a square matrix. So rank of the matrix should be always equal to the minimum of m and n. Okay? It is always valid, right? So because in most of the sessions you will find that most of the educator they always talk about rank of the matrix in terms of determinant, right? That is my experience that I have been seeing since past 10 years, right? So rank in terms of determinant is okay. So suppose suppose you have been given a matrix which is 3 by 3 matrix and you found out the determinant which is not equal to 0, right? Okay, so your rank is going to be, rank of the matrix is going to be what? 3 only, right? Rank will not be what? Rank is not going to be the less than order of the matrix. That you have to make sure. Okay, it is only applicable for square matrix. ठीक है, ये आपको याद रखना है. क्योंकि determinant of the matrix, if it is not equal to g, if it is not equal to 0, it means it is non-singular matrix. It is non-singular matrix. ठीक है, ये सारे कॉन्सेप्ट हैं. बाकी प्रॉब्लम सेशन मुझे लेना है. ओके, आई हैव टू टेक सम प्रॉब्लम सेशन. आई होप दिस मेक्स सेंस टू ऑल. ठीक है, एंड आई विल डिस्कस आल्सो some of the some of the problems. Okay, some good problems, like I will take around 20 problems, right, from linear algebra, from which can be expected in 2024, right? So I will take some top 20 problems, okay, on linear algebra, okay, and I will use all my concepts whatever I have taught you guys, right, in order to discuss. Okay, yes Devans, see you can have two situations, right? One will be non-homogeneous system of linear equation where B is there, right? Okay, in that case you get always two kind of solutions. One will be homogeneous, one will be particular solution, and homogeneous solution is nothing but the null solution. Okay, null space. Okay, we call it null solution as well. तो आपको हर वक्त आपके माइंड में आना चाहिए कि हम लीनियर सिस्टम ऑफ लीनियर इक्वेशन कैसे सॉल्व करते हैं. ठीक है, अगर ये कॉन्सेप्ट आपका क्लियर है तो आप कोई भी कॉन्सेप्ट सीख सकते हैं. ठीक है, तो पूरे लीनियर अलजेब्रा में बस यही इंपॉर्टेंट है, हाउ टू सॉल्व सिस्टम ऑफ लीनियर इक्वेशन. बस कुछ नई नई टर्मिनोलॉजीज हैं जैसे वेक्टर स्पेस, कॉलम स्पेस, रो स्पेस. अब रो स्पेस का मतलब क्या है? आप सीधा एलिमिनेशन प्रोसेस लगाओ, आप देखो उसमें कितने रोज हैं जो लीनियरली इंडिपेंडेंट हैं, राइट? वही है, रो स्पेस हो जाएगा. ओके, वही हो जाएगा आपका बेसिस. तो आपको ये समझना है, दिस इज वेरी इंपॉर्टेंट कॉन्सेप्ट. सो डायमेंशन ऑफ रो स्पेस है ना, डायमेंशन ऑफ रो स्पेस, डायमेंशन ऑफ कॉलम स्पेस. तो आई थिंक रैंक ऑफ द मैट्रिक्स, रो रैंक एंड कॉलम रैंक बोथ आर सेम. ओके, तो रो रैंक एंड कॉलम रैंक कैसे फाइंड करेंगे, मैं एक एग्जांपल से आपको बता देता हूं इन जनरल, राइट? सपोज कोई मैट्रिक्स ए दिया है and this matrix is not the square matrix, right? So you can, okay, 1 2 minus 2 1 3 6 minus 5 4 और 1 2 0 3, ये आपके पास मैट्रिक्स दिया है which is not square matrix 3 by 4, right? तो आपको यहाँ पर बेसिस अगर फाइंड करना है, ठीक है, बेसिस फॉर रो स्पेस एंड कॉलम स्पेस. ठीक है, बेसिस अगर फाइंड करना है, बेसिस फॉर रो स्पेस एंड कॉलम स्पेस, ये पहला क्वेश्चन हो गया. सेकंड रो रैंक और कॉलम रैंक क्या आता है इसका, रो रैंक एंड कॉलम रैंक, रो रैंक एंड कॉलम रैंक दोनों सेम ही आएंगे। तो आप क्या करोगे यहाँ पर, यू हैव टू गो फॉर आर आर ई एफ, राइट, just apply elimination process, okay, get echelon form, right, so you might get echelon form of this kind, right, so I'm just giving you echelon form of this, right, the matrix A का echelon form ऐसा आ गया मान लो, after applying elimination you got like this 1 2 0 and 3, and you got 0 0 1 1, right, and you got 0 0 0 0, okay, this is echelon form you got, right. Okay, so how many pivots are there, 1 and 2 pivots are there, right, so you can say that yeah, the row rank, what is rank of the matrix, rank of the matrix is 2, so if somebody will ask what is row rank, row rank is going to be 2 and column rank is also going to be 2, right, so there are only two rows which are linearly independent, okay, there are two rows which are linearly independent, so अगर कोई पूछता है बेसिस फॉर रो स्पेस क्या होगा, तो बेसिस फॉर रो स्पेस आप क्या बता सकते हो, बेसिस फॉर रो स्पेस आपका पहला रो दूसरा रो, एक ये रो हो सकता है, देखो यहाँ पर लिख सकते हो बेसिस फॉर रो स्पेस, तो अगर आपके पास मैट्रिक्स गिवन है, मैट्रिक्स गिवन है, तो वहां से कैसे बेसिस फाइंड करते हैं, अप्लाई द एलिमिनेशन प्रोसेस बस, और जितने नॉन जीरो रोज रहेंगे वही आपके बेसिस हैं, वही आपके बेसिस हैं, राइट, तो यहाँ पर बेसिस क्या हो सकता है, तो यहाँ पर लिख लो 1 2 0 3, ये एक बेसिस हो गया, और यहाँ पर कॉलम नहीं होगा, सॉरी कॉमा नहीं होगा, ठीक है, बेसिस का मतलब क्या होता है, बेसिस मींस सेट ऑफ वेक्टर्स, रो आई एम टॉकिंग अबाउट बेसिस फॉर रो स्पेस, तो आपको यहाँ पर एक और यहाँ लिख देना है, ठीक है, ओके, तो आई होप दिस मेक सेंस टू ऑल। देवांश आपको ये समझ आ रहा है ना, तो you can write here, you can write one more vector here, that is 0 0 0 1 1, या कि आप ये एक बेसिस हो गया, या आप ओरिजिनल मैट्रिक्स का ले लो, ये वाला पहला और सेकंड, दिस they can be also considered as a the basis for row space, and column space के लिए आप कॉलम वाइज लिख लो, ठीक है, क्या लिखोगे यहाँ पर, बेसिस फॉर कॉलम स्पेस विल बी दिस, जहां जहां पिवट्स हैं, एक ये हो जाएगा, ये एक ये हो जाएगा, राइट, तो हर कोई पूछता है भाई बेसिस फॉर कॉलम स्पेस क्या है, यू कैन से कॉलम स्पेस इज दिस, राइट, C of A means column space of A, you can write that 1 0 0, this is one vector, and 0 1 0, this is second vector, right, so अब कोई पूछता है भाई what is the dimension of column space, so dimension of row space is going to be telling you the rank of the matrix, dimension of column space is going to be telling you rank of the matrix, so these are the definitions that you should know, right, क्योंकि आपको केवल एक ही डेफिनेशन पता है, यस, क्योंकि आपको केवल एक कॉन्सेप्ट पता है, रैंक इन टर्म्स ऑफ, क्योंकि आप कोई भी लेक्चर देख लो, गेट की बात कर रहे हैं इंडिया में, राइट, जितने भी टीचर्स हैं, ठीक है, सब यही डिस्कस करते हैं, और आप लोगों का माइंड जो रहता है ना, केवल एक नैरोड हो जाता है, ठीक है, यू आर नॉट एबल टू थिंक बियॉन्ड, ओके, क्योंकि कोविड के पहले तक वो चलता था सब कुछ, ठीक है, कोविड के बाद थोड़ा सा सिचुएशन बदल चुकी है, ये आपको याद रखना है, ये आपको याद रखना है, दिस इज माय वार्निंग एज वेल, राइट, कि यू हैव टू स्टडी एनी सब्जेक्ट यू टेक, हम मैथ बस की बात नहीं कर रहे हैं, क्लीन अलजेब्रा की, कोई भी सब्जेक्ट की बात कर लो, थोड़ा सा आपको एडवांस पढ़ना पड़ेगा इफ यू वांट टू सॉल्व क्वेश्चंस इन द गेट एग्जाम्स, और गेट एग्जाम में चलो ठीक है तुम्हारी रैंक भी आ गई, लेकिन अभी मैं देख रहा हूँ कि पीपल आर फेलिंग इन इंटरव्यू, ओके, उनका रैंक भी 10 रैंक है, बट दे फेल इन इंटरव्यू मिजरेबली, okay, they are finding themselves miserable while giving the interview, okay, because they don't know what is the meaning of linear independence, what is the meaning of rank in terms of you can say in terms of dimension of the column space, dimension of the, what is dimension, right? तो आई थिंक आप लोग पूरे सेमेस्टर में अभी तक वट एवर एज यू बिलोंग टू, राइट, ये आपको नहीं पता रहा होगा व्हाट इज द मीनिंग ऑफ स्पैनिंग सेट। लीनियर स्पैन का मतलब क्या होता है, क्योंकि हम जब बी टेक करते हैं देयर आल्सो वी डोंट केयर अबाउट एनीथिंग, हमें लगता है बस 12th का। तो लोग जब आप देखते होंगे कोई भी लीनियर अलजेब्रा का सेशन स्टार्ट होता है, दे ऑलवेज स्टार्ट विद द डिटर्मिनेंट, प्रॉपर्टी ऑफ डिटर्मिनेंट। ये क्या है? दैट इज जस्ट अ +2 लेवल। ओके, तो देवांश ये समझ में आ गया आपको ना? हाँ, सो आई होप दिस मेक सेंस। और बहुत सारी चीजें हैं जो हमें, सो आई विल टेक सम प्रॉब्लम सेशन, ओके, एक्सक्लूसिवली। अब मेनली हमें प्रॉब्लम सेशन लेना है, और बाकी बहुत सारे कॉन्सेप्ट अभी भी हैं, ठीक है, लेकिन हम प्रॉब्लम सेशन से उनको क्लियर करेंगे अभी, जस्ट इतना ही, ठीक है। So we'll meet in the next session. This is just a 50-minute session which I wanted to plan, okay, wanted to conduct today. प्रॉब्लम सेशन में हम लोग 20 प्रॉब्लम्स लेंगे जो कि बहुत अच्छी प्रॉब्लम्स रहेंगी, ठीक है। तो अगर आपको एक प्रॉब्लम हम देना चाहें तो एक प्रॉब्लम करवा भी सकते हैं क्विकली, राइट, वेयर स्टूडेंट फेल टू सॉल्व द क्वेश्चन, ठीक है। तो मैं आपको एक प्रॉब्लम दे भी सकता हूँ क्विकली इफ आई कैन गेट दैट प्रॉब्लम, ठीक है। तो यस, okay, so what is that problem? Let me give you that problem. What is that problem? You can write and try this problem. Okay, I can give you the hint. The problem says here is that you will never find this kind of problem anywhere, right? Find the null space of the following matrix. Find the null space of following matrix, ठीक है। आपको क्या फाइंड करना है? नल स्पेस फाइंड करना है। नल स्पेस का मतलब क्या होता है? ax इक्वल टू 0, सीधा सा, ठीक है। ax इक्वल टू 0 मतलब नल स्पेस ऑफ द मैट्रिक्स, कुछ भी इसमें नहीं है। आपको पता है सिस्टम ऑफ लीनियर इक्वेशन होमोजीनियस वाला, ठीक है। तो नल स्पेस ऑफ द मैट्रिक्स आपको यहाँ पर फाइंड करना है, एंड मैट्रिक्स आपका दिया हुआ है। व्हाट इज दैट मैट्रिक्स? 1 5 6, ठीक है, 2 3 -1। ये प्रॉब्लम मैंने ही क्रिएट किया है, राइट। तो आई वांट टू जस्ट गिव यू द नल स्पेस कैन बी एक्सप्रेस्ड। देखो उसमें मेंशन भी है द नल स्पेस, ओके, can be expressed, okay, in the form of span, see, span a comma b comma 1. This is one vector they have given. The null space they are expressing in this, using this span concept, right? So what they are asking is the value of, okay, let me write properly, the value of 7a plus b आपको फाइंड करना है। What is the value? Yes. और यहाँ पर एक वर्ड है स्पैन, तो स्पैन का मतलब मैंने बता दिया है, ठीक है। तो आपको क्या करना है, यहाँ पर आपको जस्ट फाइंड करना है a की वैल्यू, b की वैल्यू, और आंसर आएगा आपका, ठीक है। तो जस्ट ट्राई दिस क्वेश्चन एंड यू कैन आल्सो कमेंट दिस आंसर इन दी chat box, okay, I mean after solving this question, try to solve this question first, right? We'll meet in the next session. Thank you so much for today. देवांश आपको if you have any doubt, let me know, right? So you can always reach to me. You know, this question is very good question that I have framed for GATE 2024 specifically. आपको ये क्वेश्चन कहीं नहीं मिलने वाला है, ठीक है। तो मैंने आपको बता दिया है that you guys can follow up, right? Okay, हम लोग फिर से मिलेंगे एक सेपरेट सेशन में, और कीप लर्निंग, ठीक है। और जस्ट because of some, I will be conducting again problem solving session. अब मुझे फोकस करना है प्रॉब्लम सॉल्विंग में मेजरली, राइट। कॉन्सेप्ट तो बहुत इंपॉर्टेंट है, आपको कॉन्सेप्ट सबसे पहले आना चाहिए, देन ओनली यू गाइस कैन सॉल्व क्वेश्चंस कॉन्फिडेंटली, और आपके फेस में हमेशा स्माइल रहेगा। और अगर आप हिले कॉन्सेप्ट आपको पता है, क्योंकि आपको पता है कि people are there who gives हिले concept, right? क्योंकि मुझे भी concept वही मिलते थे, honestly speaking, when I was preparing for GATE. तो अब आपको थोड़ा सा हट के तैयारी करना है, ठीक? So I hope this session might add some new concept in you, right? So, and do reach to me, you have my number and everything, right? So take care, good night.